Okay, let's start by reading the problem description for single number. Given a non-empty array of integers nums, every element appears twice except for one. Find that single one. You must implement a solution with a linear runtime complexity and use only constant extra space. Example 1, we can see that number 1 is the only unique number in nums, so the output is 1. Example 2, 4 is the only unique number, so the output is 4. And example 3, obviously the output is 1. For the constraints, we can see that the length of the array will be greater than or equal to 1 and less than and equal to 3 times 10 to the fourth. The values in the array will be greater than or equal to negative 3 times 10 to the fourth and less than or equal to 3 times 10 to the fourth. And each element in the array appears twice except for one element, which appears only once. To solve the single number challenge in linear time complexity and constant space, we're going to utilize the bitmap XOR operator and a single for loop. I'm going to read how the bitwise XOR operator works from the Mozilla web docs for those who are unfamiliar with it. The bitwise XOR operator returns a 1 in each bit position for which the corresponding bits of either, but not both, operands are 1s. If that description still leaves you confused how it works, that's fine. I'm going to illustrate the operations as a diagram so hopefully it becomes clear. Here we have example 2 from Leetcode, except I switched the 4 to the end of the array in hopes it'll be easier to understand how this works. We'll start by initializing a variable called XOR with a value of 0. Then we'll begin iterating through the array of numbers. Each iteration will use the bitwise XOR operator to compare each bit in the first operand to each corresponding bit in the second operand. So starting at the 0 index, we have the number 1. The bitwise XOR operator converts each operand to 32-bit integers. So the number 1 is represented in 32 bits like so. Our starting XOR value of 0 is represented by 32 zeros. So the operator is applied to each bit, leaving us with an XOR value of 1. Next we have 2. 2 gets converted to 32 bits and compared to the 32 bits of our XOR value of 1. The resulting 32 bits gives us a new XOR value of 3. The loop iterates to the number 1. It compares the number 1's 32 bits against the 32 bits of our current XOR value of 3, leaving us with an XOR value of 2. The loop iterates to the number 2, which is the same number as our current XOR value, meaning they have the exact same 32 bits. The result is 32 bits of all zeros. The loop iterates to 4. 4's 32 bits compared to 0's 32 bits leaves us with an XOR value of 4. The loop finishes and returns our XOR value of 4. Let's translate this to code. Okay, we'll begin by initializing a variable called XOR with a value of 0. We'll set up our for loop. We'll initialize the index with a value of 0. We'll check that the index is less than the length of our array. Then we will increment our index by 1 once the code block is finished executing. Then we will take the XOR and we will compare it to the current number using the bitwise XOR operator. And then we will return our XOR value. And that's it. That's our solution. Let's run our test cases. And we get the expected output. Let's copy and paste this into Leetcode. Okay, let's paste it in here. Hit submit. And we get an accepted answer.